Hi, I'm Lauren White. In this lesson, we'll talk together about how to identify electrophiles. So first, let's dig into what an electrophile actually is. An electrophile is just a species that's electron deficient, meaning it doesn't have as many electrons as it would like to have. Let's use an analogy here. Have you ever had that dream nightmare where you roll into class in the morning and you don't have on pants? You're feeling a little exposed, a little chilly. You're desperate to find some pants to cover up. Same thing here. Electrophiles are feeling a little exposed and uncomfortable, a little positive. So they're desperate to find some electrons to cover up that positive charge. The name electrophile actually tells us a lot about it. If we use our word roots, we see electro, which just means electron, and phile. Phile probably looks familiar to you as a word root. You've seen it in hydrophilic, for example. Hydrophilic means that things love water. And so the word root phile just means loving. So electrophile literally translates to electron loving. And so that makes sense because electron loving species would be trying to get more electrons because they don't have enough. Now, how do we actually go about identifying an electrophile, given that we're looking at a molecule? Well, it might be easier than you think. So, an electrophile, we said, it doesn't have as many electrons as it would like. And so you might not be surprised to know that common electrophiles have a positive charge. They're going to have a big old plus sign sitting on them, showing you that they have so few electrons that they are actually a plus charge. So we can look at something like a carbocation. In this case, we have a tertiary carbocation since it's connected to 1, 2, 3 other carbons. And when we see these molecules given to us, we'll see that big fat plus sign sitting on that carbon. Now, keep in mind, it doesn't necessarily have to be circled like this one. It could also just be a plus sign. But anytime you see a positive charge, you know that is an electrophile. Now, that's not the only way to have an electrophile. It's certainly the easiest to spot, but there are other ways that we can get electron-deficient atoms. So for organic chemistry, what you need to know is that if we have one atom bound to another electronegative atom, then that first atom is going to be electron deficient, and it will be an electrophile. So, for example, we can look at something like a carbon-oxygen double bond. We call this a carbonyl group. Now, remember from Gen Chem what electronegativity means. Electronegative atoms are kind of like the atomic version of a blanket hog. Have you ever been sitting on the couch with a friend and all of a sudden you notice that they're wrapped up in the blanket and you have none? Oxygen kind of does that with electrons. It wants all the electrons, and so it will pull those electrons towards it, no matter what it does to the other atoms around it. And as it turns out, what it does to the atoms around it is makes them slightly positive. And you'll see this written out on a molecule as a delta plus. This literally just means it's slightly positive. Now, in this atom, we can see that we have this double bond. The double bond kind of acts like an electron superhighway to allow oxygen to pull lots of electron density towards it. So our carbon here is very partially positive, and as it turns out, our oxygen then is very partially negative. So the electrophile here, even though it doesn't have a full positive charge, carbon is an electrophile in carbonyl groups. So let's look at some examples of identifying electrophiles. This question is asking us to identify the electrophilic center. So where in this molecule would the electrophile be? Whenever we're doing this, we always want to look for the classic tells. We want to look for a full positive charge. That's the easiest way to spot it. Or we want to look for a bond to an electronegative atom. So let's do that. Let's start with A. Now, at first, this is just your typical carbon skeleton, right? I don't see any positive charges, but I do see bromine. Bromine is an electronegative atom. Just like oxygen, it's going to pull those electrons towards it, it's going to hog all the electrons, and it's going to leave whatever atom it's attached to with that slightly positive charge. So in this case, we're talking about the carbon connected directly to the bromine, and it's going to have a slightly positive charge, and it will act as an electrophile. All right, let's look at B. This should look familiar to you. We talked about a carbon-oxygen double bond, and anytime you see a carbon-oxygen double bond, you should think that carbon is an electrophile. So again, we have our carbon-oxygen double bond. Oxygen, as usual, is an electronegative atom. It's going to hog all those electrons towards it. It's going to leave the carbon it's connected to slightly positive. So this carbon connected directly to the oxygen, that's going to act as an electrophile. Finally, let's look at C. Now, when we look at C, good news, the first thing we see is this giant positive charge sticking out on that carbon. That means that that carbon, for sure, is an electrophilic center. But we're not done yet. Because if we look, we also have an oxygen down here. Now, even though this is not a double bond to an oxygen, it is still a bond to an oxygen, and oxygen will still be able to pull electrons towards it and hog them all away from the carbon. So, just like we saw with our carbonyl group, the carbon directly attached to that oxygen is going to be slightly positive and can also act as an electrophilic center in this molecule. So this molecule has two electrophilic centers, and you'll learn in a later video how to decide which one of these is going to react. Now, you should feel more comfortable identifying electrophiles as atoms with positive charge or atoms that are bonded to another electrophilic atom.